The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody, and welcome to the June edition of We Speak Linux. Thanks for coming in and watching our webinar, or if you're watching later on remotely, thank you for checking it out later. So We Speak Linux is designed to help Windows administrators and developers learn the wide world of Linux. We are doing monthly webinars. We also have blog posts and a Slack channel where we can offer up some peer support, trying to get people to become multi-OS. We want to grow the group of Windows developers and administrators who are ready to transition to Linux, who are able to take advantage of some of the interesting things that have been happening over in that space that maybe you haven't seen in the last couple of years. So speaking of webinars, today's topic is calculating top 10 lists in Bash. It's by Thomas Limoncelli, who I'm going to hand it over to in just a couple of moments. One big thing is that if you're interested in asking questions during the talk, join us in Slack for that. We're in the webinar chat channel, and if you need to get onto Slack, you can sign up through wespeaklinux.com. You can also use the chat here in the GoToMeeting webinar, and what I'll do is answer any questions that I can, and we're going to save the most interesting ones that I can't answer for Tom at the end. Please subscribe to our newsletter. It's on our main page at wespeaklinux.com. If you're interested in Slack, join our Slack channel. You can also hit us up on Twitter, and we post all of the webinars on YouTube afterwards. So this webinar should be going up not too long after the chat. We have webinars on the first Thursday of every month. The next couple of months, we've got a couple of great speakers. The first one is Argenis Fernandez, who now works for Microsoft. He is going to be giving a talk on containers on July 5th. Then we're going to have Jessica Dean talk about Kubernetes. So those will both be very interesting talks, I'm sure. And with that, I'm going to hand it over to Tom, and he'll take it away from here.
Hi there. Thanks, Kevin, and thanks for inviting me to the show. I remember when I first started exploring Unix, or Linux is a clone of Unix, so us old timers, refer to Unix. And I just remember everything I learned about Unix. It was like exploring a new land, and it was so exciting and fresh and new. And I was super lucky that I had a mentor, someone that I could talk to and ask questions. And I know that not everyone is so lucky, and I'm so glad that you do this podcast, because I kind of think it gives opportunity to people that don't have that opportunity that I had. So let's see. Let me share this. Okay. So as Kevin mentioned, the title of my talk, Calculating Top 10 Lists in Bash, which is probably the most boring title in the world. But then part 2, and how I use Bash to hunt a virus, that hopefully makes up for the boringness of the title. A little about myself. I am the Site Reliability Engineering Manager, or SRE Manager at StackOverflow.com. Hopefully all the viewers or listeners to the podcast are familiar with StackOverflow.com. We love helping people learn. And just a side note, we're hiring Linux people in Denver and Windows people in New York City, so feel free to contact me. As I mentioned before, I'm kind of an old timer. I've been a system administrator since 1988. I've worked at Google, Bell Labs, Mentor Graphics. My time at Bell Labs was very interesting, because Unix began at Bell Labs, and I was the sysadmin, one of the sysadmins on the network that included some of the inventors of Unix. So I got to meet them, and that was a wonderful 7 years at Bell Labs. I blog and I tweet, and I have a quarterly column in ACMQ magazine, and I've written a number of books that I listed down at the bottom of the slide. So today we're going to go through a couple different exercises. We're going to find the most frequent item in a list, and then we're going to find we're going to use that to find the most frequent IP address that has access to my website. So that's a little more practical. Someone might ask, who's been accessing our website the most? The third exercise, we'll use the same. Actually, I'm going to switch the order. We're going to do the fourth one first. We're going to do the most frequent ARPers on a network. I'll tell you what that means in a bit. That relates to finding chasing down a virus that was on a network where I worked a couple years ago. And then we'll end with this number 3, with the most frequent words. We'll find the most frequent words in the document. And that's kind of like the bonus item that we'll do if we have more time. Okay, so let's move to the exercises. Let me screen share. There we go. Okay, so you should be able to see my bash shell right now. So the first thing we're going to do is, well, actually, before we get to the exercises, I'm going to review a number of commands in bash. These are commands that, by knowing them, it'll make the exercises a little more easier to understand. I'm going to assume for these exercises that you're very, very new to Unix/Linux. And so for some of you, this might be too basic. You might want to skip forward 5 minutes in this video. But no matter what, it's probably a good refresher. So let's warm up with some basic commands. As you see on the screen, I've typed the ls-l command. ls lists the files that are in the current directory, and -l gives the long version of the output. So it lists permissions and file sizes and dates and other things. Without the -l, you get just the list of files. Another useful command, or a command that we'll be seeing a lot, is the cat command. Cat, if you give it a file name, like we have, I have this file called stairway.txt. When we run this, it's going to output the contents of the stairway.txt file just onto the screen. This text file is, it contains the lyrics to Led Zeppelin's Stairway to Heaven, which, by the way, is the most important song in all of rock and roll. Write that down if you're taking notes. It'll be on the quiz later. Okay, so we press return, and it just outputs the contents to the screen. Now, if you notice, the lyrics for more than would fit on one screen. There's another command called more. Stairway more is like cat, except it stops every screen full of text and asks, do you want to see more? And so I ran that, and as you see, it showed the first part of the file. We're at the 76% mark, and it's saying, do you want to see more? You press spacebar, and it shows more, and press spacebar again, it gets to the end. More, not a lot of people use more anymore because more has been replaced by a more featureful command called less. I'm going to be using more in this in these examples, but more and less both do similar things. One thing you'll notice is a lot of the commands in Unix have strange names, and I'll have a link for the show notes that explains the history behind a lot of these commands. As I said before, more is named that because it asks, do you want to see more every screen full? And less was kind of a joke. It was, we're going to make something that's better than more. What would be more better than more is less. And I also showed you the cat command. What is cat? Is it a reference to an animal? No, it's actually short for concatenate, because it accepts multiple files and it concatenates them. So if we concatenate, just means join. So cat, if we have this names file and then this numbers file, it's going to output the names file, then the numbers file right away with no break between the two. Which press return and we see that doesn't seem so useful. Like why would that be important? Well, the reason that's important is because you can, in Unix, you can redirect the output of a command. And so for example, so the greater than symbol redirects the output of this command to a file. So we're going to call this result.txt. So this is going to concatenate names and numbers, in other words, output all of them, and send, instead of sending them to the screen, which is the default, we're going to say send the result to this file called result.txt. And that's why it's called concatenate. In addition to directing the output of commands using the greater than symbol, we can also direct the input to commands using the less than symbol. So if you remember before I said cat names.txt, if there's only a single file, you could say less than, and this tells cat that it's just another way of listing the input. In this case, we're saying take the cat command, connect the input of the cat command to name, and maybe we want to say send the output to a file called out.txt. Oops, it's not called name, it's called names plural, right? And so in this way, cat is very much like the copy command, the CP command, which copies files. Now, why are there two commands for the same thing? Well, I'll show you in a little bit. This is really just a demo to show that how you can redirect input and output to a command. A more useful example would be there's a sort command. Sort, if we send it the input, our names file, and send our output to, let's say, names.txt.sorted, that's a more useful command. Sort takes its input, sorts it, and sends it to the output. And because we've connected the input to names and the output to names.txt.sorted, it did what you expect. If we cat names.txt.sorted, we see the list of names, and now they've been sorted. There's another way we can connect the input and output of commands. Let's do that command we did before. We have this names file and numbers file. We're going to cat those. Oh, actually, I think we did this before. We're going to pipe. So before we use greater than to redirect the output to a file. We can also use the pipe, which redirects the output to another program. And so here we're taking cat, where we're concatenating these two files and piping it or redirecting its output. Its output becomes the input to more. So that looks like this. When we press return, cat is still concatenating first the names file, then the numbers file, and more is gathering that information and showing it to us one screen at a time. And I'm pressing spacebar each time to get the next group. Now, you might say, well, why doesn't cat just have a flag that says I want to, page the information one screen full at a time? Well, the reason is that you could in theory want that kind of feature on every command. Like the sort command, it might be useful to have the sort command show its output one screen full at a time. And so, you might want, you might end up asking like the author of cat to add this feature and the author of more to sort to add this feature, and you could ask almost every command in the Unix world to add this feature, and that's pretty redundant. Doing this, you can all commands. No command has to add this feature because all commands can just send their output to the more feature. And this is pretty cool. You can actually make longer chains of commands. So let's cat those files, pipe them to sort, and pipe that to more. This is connecting 3 different commands. So cat is going to output the contents of the files, sort will sort it, and more will ask us to, or will let us view one screenful at a time. And so let me demonstrate what that looks like. So because sorts numbers in front of letters, the numbers go first, then the letters, or then the names, and I'm pressing spacebar each time to go through the file. This was actually considered quite a big innovation in Unix. One of the Unix originators, Doug McElroy, came up with this concept in the early 70s. And what mathematicians, by the way, they call this composing functions, but he inspired the people that were inventing Unix. He said, wouldn't it be great if all the Unix commands if each command did one thing, but you could combine them? And he used this garden hose analogy. He said, wouldn't it be nice if you could just screw them together like parts of a garden hose and send the output of one command to be the input of the next command? You could just make these long pipelines. And in fact, this pipe character is called the pipe character because of the Unix tradition of piping the output of one thing to the next. Anyway, that was a big innovation in its time in the early 70s. Now it's something that all operating systems do. Okay, so enough Unix history and background. Let's get to the first exercise. So our first exercise is we're gonna determine which item. We're gonna do a frequency count of each item in a list. So let's look at this file called names. I'm gonna say it's cat take the input from the names file, and here's the names file. If you look at this, Larry appears once there and twice more there. Now there is we're going to send the output of cat to this program called unique. Now what unique does is it removes duplicates, leaving you with a file that is only unique lines. But the unique program, it's very dumb. It can only remove adjacent duplicates. So it's going to remove this double Larry here, but it's not smart enough to know that there was a Larry 8 lines or 10 lines earlier. So let's run this. And you see it did remove the duplicate Larry, but the single Larry, it didn't remove the fact that Larry appears twice. So how are we going to do this? Well, we're going to pipe names to sort and then to unique. And that's going to, actually, let's just run the first part. So this sorts it, and then, oops, and then sort, gathers all the Larrys together, and unique will remove it. Now, the goal here is to create a frequency chart, not to remove duplicates. And luckily, unique has a flag -C, which reports a count of how many times it sees each item. So, so here we see the output is, it saw Larry 3 times and everything else was seen once. So this is a frequency count, but the assignment was to do a top 10 list. So how would we do top 10? Well, we're gonna sort this frequency. Sort has a feature, the -N flag sorts numerically, and since this first column is numbers, we have to tell it to sort by numbers. And that's going to put Larry at the bottom because it's sorting these all tie for I guess second place, and this is the most frequent word. And since I did say top 10 list, we're going to then pipe that to tail. Tail is a command that takes, you could send it all the input in the world, but it ignores all the input except the last, well, the default is last 10 lines. So that it truncates. It basically gives you the tail of the file, the end of the file. And we could say it takes a -n option if we want to see the last 15 items. But the homework assignment here was we wanted a top 10 list. So here's the top 10 most frequent names. Now this is kind of a bad example because so many different things tied for second place. But it's kind of just a silly little example. The next example is going to make a little more sense. Kevin, are we seeing a lot of questions on the channel? Is this clear?
You're clear so far.
Okay, great. Okay, so the next thing we can do, the next goal, exercise 2, is to print the most frequent IP addresses that have access to my website. Now, every time someone accesses, or first let me tell you a little, I have a number of websites, and one of them is called Best Spaghetti Sauce Ever. It's literally just a website that just shows my mother's spaghetti sauce recipe, and it has ads, and I don't want to brag, but the advertising revenue from this makes me about $3 a year. So by 2021, I'll have enough to buy a hamburger. I'm very excited about this website, big success. And in this file, we have the Apache log, or the access log. So this is every time someone accesses this website, a line gets appended to this file. And we're gonna look at, let's look at the first line of the file. So I'm gonna use head. Head is like tail, but it shows the beginning of a file. And -n1 means show only the first line. So the first line of the file, and every line in the file is like this. It begins with an IP address, and then 2 dashes. It's a long story what that means, but then the date. So this is when someone went to my website. So March 23rd, this is 2015, when the log file started. The exact HTTP command that they issued, get. The important thing is get / which means they asked to see the home page of this, and a whole bunch of other information. If we look at the first 2 lines of the file, we'll see, so here's that line again, and here's the next person to access was at this IP address, yada, yada, yada. I can cat the whole file, 1, 2, 3, 4, 5, 6, this is gonna take a long, okay, about 7 seconds. Yeah, I made a snapshot of this file on June 5th. So this is, yeah, from the middle of 2015 to 2 days ago, all the accesses on this file. So, so the goal here is to find out which IP address has accessed my website the most. We're gonna try to do a top 10 list. So we're gonna, to do this, we need to extract out the IP address. How do we extract out the IP address? Well, luckily that IP address is the first column. So we're gonna use a Unix command called cut. And we're gonna do cut, let me type this and then I'll explain it. Okay, so cut takes this flag D, says the delimiter in this file is a space. So it's saying that this is a space delimited file. You might be familiar with comma separated or tab separated files. This is comma separated. -F1 means extract out field number 1, which is the IP address, and we're sending as input to the file this this log, and the command's getting very long. It's wrapping around to the next line. Oh, let's just run this as is, and here we see all these different IP addresses. Again, that takes about 7 seconds to go through it all. And we want to do a top 10 list, so we're going to, just like we did before, we're going to sort the input. We're going to call unique-c, and then we're going to sort that numerically. And we're going to see this idiom in all of these exercises. We sort, unique, sort. So, or sort, unique-c, sort. So sort, gather everything so that the duplicates are adjacent, count the duplicates, and then sort numerically. And then since we're not piping it anywhere else, it's going to go to the screen. We're going to see this idiom lots of in all of these exercises. Okay, so let's run this. And there we go. So the most frequent person to access my website is 127.0.0.1, which is localhost, which means the website itself, which happens to be the monitoring system. So what this is saying is that the most frequent person to access my website is my own monitoring system, which is almost 3 times as many accesses as the number 2 access. Who's this guy? So dig dig is a command that does a reverse DNS lookup with the -x. So this is some user at an ISP called atlanticbb.net. I won't look up the rest, but yeah. So now one last thing. This is the homework assignment, so to speak, was to look at the it was the top 10 lists. So tail -n10. To be proper, here's our 10. Okay. Now, knowing who's accessed my website for the last 3 years is not as interesting as knowing who's accessed it on maybe a specific date or a specific hour. So let's do a little variation of this. grep is a command that searches a file. So if I type grep December 2nd, which is not a random date. This is my birthday. So let's say who is the most frequently, which IP addresses accessed my website the most last year on my birthday. We're going to grep for files that mention that date. We're still going to send as input best spaghetti sauce. And what grep does is in this format, it only shows you the lines that contain that string, this string here. So we're going to, so let's take that. We're going to do what we did before. We're going to cut with the delimiter space, field 1, just to extract the IP address, and then our idiom sort unique -c sort -n. You might notice I tend to run commands when they're only half finished. This is something I encourage everyone to do. The great thing about Unix is you can build up these really long command lines, and I encourage you to, as you build it, run it at each stage so that you're kind of debugging it as you go along. I know there's been times where, for example, I wasn't sorting on the first column, I was sorting on like the 7th column, but I miscounted, it was actually the 6th. And because I ran the intermediate, short versions of the command line, I saw that like, oh, 7 wasn't working. And so then I realized, oh, I miscounted, it should have been the 6th. And I solved that problem there before I added more pipes to the command line. Okay, so now we run this. Oh wait, I promise this is a top 10 list, so we're going to say tail. The default for tail is 10 lines, so I actually don't need to do -n10. But yeah, so on my birthday last December, these are the computers that most frequently accessed my website. And we could even do just a particular hour. If I remember correctly, the date format was day, month, year, : hour. Yeah, so this is at 4 a.m. This is who was accessing my website, which is, you might be thinking, who are all these people accessing Tom's little spaghetti sauce website? Well, these are probably not people. These are probably web crawlers, spiders like Google and Yandex and other people that are indexing websites. Anyway, Okay, so that's the end of that exercise. Let's move on to the next exercise. So those were kind of contrived. Well, actually, that last exercise wasn't too contrived because, I mean, plenty of times we want to know who's accessing a website and do that kind of analysis. But this next exercise is it's very different because it deals with some network data. So there is a Unix command that it's a network sniffer called tcpdump. tcpdump opens, gains access to your Ethernet NIC on your computer and watches all the network packets that are passing through your NIC, which is it's kind of like a little spy tool. Now, because that's there's privacy issues involved in that, only root can run tcpdump, so we're going to run this under sudo, and it can't see all the packets in the network. It can only see the packets that are somehow visible to the computer that it's running on. If you notice, I switched to a different machine a second ago. This machine, it's here at the Stack Overflow data center, and it's positioned in a place in the network where it doesn't actually have visibility to much traffic, but it has access to some. And you can check the tcpdump man page to see what these options do. But essentially, what this is doing is it's saying, watch the network and only tell me tell me every time you see a network packet that is an ARP packet. ARP packets, let me just enter my password. Okay. ARP packets are essentially every time a computer needs to talk to, the first time a computer talks to another computer on the local subnet, it sends out an ARP packet that means, hey, I'm trying to talk to so-and-so replies, oh, yeah, I'm here, and then they're able to talk to each other. And what I've done is, and these are the individual packets that you've seen. So there's one line per packet. Now, I previously captured a bunch of those packets and saved them to this file, packet.tcpdump. And tcpdump lets me read this file as if it was sniffing the network. The reason I'm doing this, so I saved a bunch of packets yesterday in preparation for this class. The reason I did that is I want to run these experiments on the same exact packets every time, just for consistency. So as a result, so I saved the packets earlier using, actually it was tcpdump-w to write the file. Now I'm going to read the file, and -nn, that just means show me the IP addresses. Don't try to do reverse DNS lookups. Okay, so these are the packets. Now, okay, let's review. What was the assignment? The assignment was we want to figure out who the most frequent ARP packets have been, or who is generating the most ARP packets on this network. So what we're going to do is we're going to extract out this column. So because this is the computer that generated the ARP packet, and that's, let's see, 1, 2, 3, 4, 5, 6, 7. That's the 7th column. So we're going to use cut again. The delimiter is still a space, and it's column 7. And let's see if I counted that correctly. I did. Look at that. Those are the IP addresses from before. And now, if you notice, this isn't perfect for two reasons. One is there's a comma on every line. We could ignore that. If we wanted to, we could clean that up a little. And sometimes those lines, have either the word tell or length in them. Let's see what's that about. Okay, so let's pass this data through grep. So we're going to take only the lines that are definitely these ARP packets, and then we're going to cut. Oops, D7. Okay, that's a little bit better. Well, now we're still getting the tell lines, but that's okay. We'll just manually ignore them. One of the things I'm trying to drive home here is as we build up these command lines, don't worry about bugs. I mean, I know a lot of developers or people that are new to computers that are like, oh, I tried something, it didn't work at the first time. I must be a terrible person. I'm never gonna be good at computers. I've been using Unix since 1988, and I never get anything right on the first try. That's just the nature of things. And that's why, that's part of the beauty of building pipes is you can just build these incrementally. You know, if I guess what column wrong, no problem. Maybe I did 6 at first. I learned, I realized it's 7. I update the command line. I'm just coding as I go. So now we have these IP addresses. We're going to use our idiom from before: sort unique-c sort-n. And this is who is generating the most ARP packets. Now, if you notice, these two machines are generating more than 3 times as many ARP packets as number 3. What does that mean? Well, this IP address, I happen to know that that's the IP address of the router on the network. Now, it makes sense that the router is trying to do a lot of ARP packets because being the router, it talks to a lot of different machines. And if the ARP packet is how you say hello to a machine you're talking to for the first time, then that totally makes sense. But this machine, that's interesting. Why is that talking? Well, last night I did a little investigation, and it turned out this machine is actually misconfigured. It's trying to talk to a machine that doesn't exist anymore. So like every couple seconds, it's repeating this ARP message. So I actually, in preparing for this class, we actually found a misconfiguration in the network, which is something we're going to clean up. Now, I promised that I was going to say about how I use bash to find a virus that was on our network. Many years ago, I was working at a small company, and we had a virus outbreak in one of our sales call centers. I was in the New Jersey office, but this was happening in the London office, and this virus outbreak was generating so much traffic that it was actually causing a disruption of service. And so I talked to the people in the London office. I managed them remotely, and I said, okay, I need you to walk to every single salesperson's machine and make sure that they didn't disable their virus scanner. Well, they walked around and they did find a couple people that had disabled their virus scanner, and they re-enabled it, and the virus almost totally went away, but we were still having a problem. And I said, well, make sure you've visited every single PC, and they assured me that they had, and I said, well, what are we going to do? And I basically ran this exact kind of command. Because we knew that the way that the virus spread was it tried to find all the other machines on the network, and as a result, it was generating a lot of ARP packets. So so I did this TCP dump of ARP packets on that network. I passed it through this very same, similar kind of thing with the idiom sort unique sort that we learned before. And there was one machine that was generating like 10 times more ARP packets than all the other machines. And I said, aha. And I looked up the name of that machine, and it was like Joe Smith PC. And I called back my employees in the London office, and I said, go to Joe Smith's PC. I think his virus scanner is still disabled. And funny enough, I had only joined the company a month ago, so I hadn't even met half of the people that I was managing in the London office, and they were like, oh no, is our new boss psychic? How does he know it's Joe Schmo? And so they walk over to Joe Schmo's machine, and he had really disabled his virus scanner, And they're like, uh-oh, our new boss, he's crazy psychic. We better, that's just weird. And but that's how I used Bash to track down a machine with a virus. Okay, so we do have enough time. I said that we'd do a fourth exercise if we had time, and it looks like we do have time. So this last exercise is we are going to find the most frequent word in a text document, or the top 10 most common words that are in a text document. And the text document we're going to use, oops, let's go back to that other machine. Okay, so I have this file, Stairway, which, as I mentioned before, is the lyrics to Stairway to Heaven, the most important rock and roll song of all time. And we are going to figure out what word appears most frequently in this song. Now, there's a couple challenges here. First challenge is that some of these words have an uppercase letter, and unique is not a very smart command. It thinks that yes with a capital Y is different than yes with a lowercase y. And so the first thing we're going to need to do is we're going to need to downcase all the words. The other thing is there are commas and periods and all sorts of punctuation in this, and that's going to confuse our little sort unique sort pipeline. So we're going to have to remove the punctuation. And the third thing that we're going to have to do is, well, we're going to have to change this from a sentence per line to one word per line, right? Because we want to make, that's going to be required to sort things. Okay, so let's do those three things. The first thing we're going to do, we're going to cat Stairway to Heaven, or stairway.txt. Now, how are we going to downcase everything? Well, there's a Unix command called tr, and tr takes two strings. If we do, say, ABC and 1, 2, 3, what tr does is it translates. So it's going to take the input and it's going to translate every place it sees the letter A, it's going to change it to a 1. And every time it sees the letter B, it's going to change it to letter 2. And C, it's going to change it to letter 3. Now we're not actually, that's not the translation we're going to do, but just to show you, if we run that command, see the walks became W1 LKS. So we know the command's working, but that's not actually what we're going to do. What we're going to do is we're going to turn capital ABC into lowercase ABC. So that's how we're going to downcase everything. And actually, I could type D, E, F. I could type the whole alphabet, but luckily Translate has a little shortcut. It knows that if you say a letter dash another letter, it means the whole alphabet. So we can translate all the uppercase letters to lowercase letters. So let's do that. Yep, that seems to have worked. Okay, so that's the downcase. The next thing we want to do is we want to get rid of the punctuation. Let's turn commas and periods and quotes and turn those into spaces and spaces and spaces and spaces. If you notice, I had to put both of these in quotes so that Bash knows that I'm not just typing spaces, I'm typing a string that is a bunch of spaces. So let's run this now. Where is there okay, so dear lady has a comma on it. When we run this, we want to make sure that that comma became a space, and it looks like it did. Yep. And I'll tell you a little trick. If you, we actually only needed to do one space in this second string because if this string is too short, it just assumes that that last, whatever you typed last, that last character is repeated as many times as needed In other words, if these two strings aren't the same length, it would just assume that the last character is repeated. But anyway, we could verify that by pressing return and see that we got the same results. Okay, cool. Okay, so we've downcased it. We've removed the punctuation. How are we going to break each line into the individual words? We can use the FMT command -1. FMT-1 means break. We'll do what we need. By the way, you after this talk, you might want to go through the man page, the manual page on each of these commands. I'm using usually just only a small fraction of what these commands do. They're usually very powerful, and reading the man pages is a great way to learn about all the different things that they can do. So let's try this. If we do pipe all that to format -1, we get everything on an individual line. Great. So now we can do our idiom sort unique-c sort-n. Oh, and tail, because we wanted the top 10 most frequent words in this song. And there we go. And if you notice, and you probably could have guessed that the most frequent words, because any corpus of text that you use, most frequent words are probably going to be a, to, and the. In fact, in the publishing world, these are called stop words. These are the words that you do not index because they appear on every page of a book. But there we have it. We have we've built up this very long command line. Like Doug McElroy said, we've piped these together like you're connecting parts of a garden hose. We wrote the command incrementally. We built it up one part at a time so we could test that the next edition did what we thought it did before we went and added the next part. And that's it. So let me switch back. I have a conclusion slide. And hold on one second as I switch back to Keynote. Okay, so here's some useful links. Shameless plug, I did mention that we're hiring, but also Rob Pike has this excellent article written many years ago about how this philosophy, this Unix philosophy of little commands doing one thing well that combine well together to do fabulous things. A little about the history. I mentioned Doug McElroy a couple times, so this is an article about him and his life, amazing computer scientist. I found this link very useful. It's I mentioned that Unix commands often have obscure, weird, funny names, and this is an article that explains some of those names. I mentioned that I have a column in ACMQ, and here's the URL for that. And also, please enjoy my mother's spaghetti sauce recipe. I guarantee that it is the best spaghetti sauce you will ever have. And that's my presentation.
Hey, thanks a lot, Tom. So the biggest question that I have out of this, is it a thick sauce or a thin sauce?
Good. It's a thick sauce and it's a meat sauce. In fact, people have written to me saying that they tried it and they were surprised that they didn't add salt. But there is so much, the salt actually comes from the meat because you use 4 different kinds of meat and it becomes very thick and rich. Good question.
Yeah, the questions in chat were fairly straightforward. I was able to take care of them. So sounds like you did a great job explaining.
Thanks. Well, I really had a great time, and thank you so much for inviting me, Kevin.
Thanks for being here. So wrapping things up, next month, as mentioned, Argenis Fernandez will be talking about containers. And with that, we hope you'll be able to tune in then. That'll be Thursday, July 5th. If you're already signed up for the recurring webinar, you'll be able to see it, get an email a day early, and hope to see you there. Thanks for attending, everybody, and thanks for watching on the video.